Assalamu alaikum. How are you, everyone? Today we will continue in this video. We will continue part 2 of chapter 8, lesson 2, types of chemical reactions. In part 1, we talked about synthesis reaction and decomposition. In this part, we will talk about single displacement, double displacement, and combustion reactions. Okay, so we will start with single displacement. In a single displacement reaction, as we mentioned before, it's a reaction between an element plus a compound, an element plus a compound. Single displacement reaction, it has two options. Either it will occur or it will not. So either there is a reaction or there is no reaction. So let us read the definition of single displacement reaction and the general formula. Then we will go through or we will go in details for this type of reaction. In single displacement reaction, which is also known a replacement reaction, which one element takes the place of another element. One element replaces a similar, please be careful in this part, a similar element in a compound. Yani one element try to take the place of another element which is from the same category. When I'm saying same category, yani metal try to replace another metal, or non-metal try to replace a non-metal. Okay, many single displacement reactions take place in aqueous solution. Single displacement reactions can be represented by the following general equation. Element A is an element plus Bx as a compound. Here is A is a metal, B is a metal also. A is more reactive than B, so the new compound is AX plus B, or Y plus BX. Y is a non-metal. And you know that always the first element in the chemical formula, if it's ionic compound, the first element always metal, and the second element is non-metal if it's an ionic compound. Okay, so Y will fight with X. Okay, they will fight. If Y is more active than X, so it can replace the X, or Y can take the place of or the position of X, and a new compound is formed, By plus X. Okay, we write By, not Yb, because as I mentioned, always the positive ion comes before the negative ion comes first. Okay. Now, single displacement reaction depends on activity series, or reactivity series, depends on the reference. So in this table, as you can see, table 3, activity series of elements. This table is divided into 2 columns, 5 rows. Why did we divide it into 2 columns? Because the first column is talking about activity of metals, okay, and the second one is the activity of halogens, non-metal. Okay, type. This is the first part. Second part is divided into different groups or series or categories, whatever you like to call it. It divides into 5, 1, 2, 3, 1, 2, 3, 4, 5 rows. Why? Later on, I will talk about this one. But first, I want to talk about the trend of these metals, these metals. When you go up from up to down, the reactivity of the elements, the reactivity decreases. Okay, you go from up to down. Okay, the reactivity decreases. So lithium here has the highest reactivity, and gold the lowest reactivity. Okay, so lithium has the highest reactivity again, and gold the lowest reactivity. Also, lithium is more reactive than potassium. Potassium is more reactive than sodium. Sodium is more reactive than magnesium. Iron is more reactive than cobalt. Okay, lead is more reactive than copper. So the element that comes first is more reactive, okay? The element that comes first is more reactive. This is point one. This is point one about the reactivity series. So again, I will just draw. So you go from the first row to the till the end, the reactivity of the element decreases. Okay, this is the first part. Second part, that if you look here, as we said, it's divided, the reactivity series is divided into 5 series or 5 categories. Okay, why we divide these elements into 5 series? Because these elements, which is located in series number 1, in series number 1, elements of series number 1 react with cold water. Cold water means liquid, okay? And acids, replacing hydrogen, reacts with oxygen, forming oxides. Where elements of series number 2 react with water, but the water must be in gas state and reacts with steam. Steam means water in gas state. Okay, H2O gas. So if you have Fe plus H2O liquid, Fe plus H2O gas, again, okay? Here, there is no reaction. No reaction. Why there is no reaction? Because any element from this series, when it reacts with water, water must be in gas state, not in liquid state, okay? But if you have another reaction, iron plus plus H2O gas, iron plus H2O gas, there is a reaction and the product is Fe2O3 plus hydrogen gas, okay? Hydrogen gas here solid. Then don't forget to balance the chemical equation, okay? In this example, as you can see in these two examples, when iron reacts with water, liquid state, there is no reaction. When iron reacts with water in gas state, there is a reaction. And the products are two products, iron 3 oxide and hydrogen gas. Okay, this is the second point about the reactivity series. One more point about the reactivity series. So we said when you go from up to down, the reactivity of the element decreases. This is the first one. Second point, that not all elements react with water. Some elements react with water at liquid state, some at gas state, and some of them do not react with water at all. For example, copper plus H2O, either liquid or gas. Both cases, no reaction. Why there is no reaction? Because as it's mentioned here, okay, copper react with oxygen only. From series number 3 and 4 and 5, from series number 3, also 4 and 5, do not react with water at all, either liquid or gas, okay? This is the second or the third point here. Now, another note about the reactivity series. For example, Al plus calcium chloride, okay, aluminum plus calcium chloride. Wherever you see an element and a compound, so direct you'll say that this is single displacement reaction. Single displacement. We said single displacement reaction either yes, yani it will happen, or no, it will not happen. Okay, how I can know it will happen or it will not happen? Look at this element. Aluminum is a metal, so it will try to replace another metal, which is calcium, not chloride. Okay, so how I can know if the aluminum can replace the calcium? Does it have the enough energy to replace calcium or not? Is it stronger than calcium or it's weaker than calcium? How I can decide? I can decide based on the reactivity series. Point out or figure out the aluminium, it's here, and the calcium above of aluminium. If calcium comes above the aluminium, it means that the aluminium is weaker than calcium. What I mean by weaker means that it's less reactive than calcium. So Al less reactive than Ca. Al less active than Ca. So it cannot replace the calcium, so there is no reaction. Okay. On the other side, if there's calcium plus AlCl3, okay, sorry, it's not writing. Okay, now, as we said, an element plus a compound, mostly it's single displacement reaction, either yes or no. How I can decide? Look at this metal, this element, it's a metal, so it will fight with another metal, which is aluminium. Either it will win or it will not. So I can decide based on the reactivity series. Calcium comparing to aluminium, calcium is more reactive than aluminium, so yes, it can replace the aluminium, CaCl2 plus Al, okay, plus Al, then multiply by 3, multiply by 2 here, and multiply by 2, 3 this side to balance the chemical equation. This is another point about reactivity of elements. The last point that I want to talk about is when elements from series number 2 and elements from series number 2 react with water. For example, Na plus H2O liquid and Mg plus H2O gas. Sodium is from series number 1, can react with cold water, so there is a reaction. The product is sodium hydroxide. You know the hydroxide is OH and the charge is -1, so sodium +1, 1 to 1, no need to write the 1, plus hydrogen gas, H2O gas. Where a metal from series number 2, when it reacts with water in gas state, it's mentioned steam, the products are metal oxide, not metal hydroxide, so it's MgO. Why it's MgO? I will do it here, Mg +2, O -2, switch the charge, simplify, Mg2O2, then simplify, it's MgO. Okay, this is not our lesson, but yani, so like to remember how to write the chemical formula, plus H2 gas. So in both cases there is hydrogen gas, okay, but the difference between metals from series number 2 and metals from series number 1 and metals from series number 2, when they react with water, the products. One of the products is metal hydroxide and here metal oxide. So the product is metal hydroxide plus hydrogen gas, here metal oxide plus hydrogen gas when they react with water. I'm talking about the reaction with water, okay? This is the general ideas about the reactivity series. So let us take example like one example for single displacement reaction. For example, aluminium. I'll take the example here. Aluminium with lead nitrate. Aluminium plus lead nitrate, PbNO3. The charge of lead is positive 2. Okay. Now, I said whenever you see an element plus a compound, so it's single displacement reaction. Single displacement reaction, either yes, it will happen, or no, it will not. Okay, no reaction yet. Either yes, there is a reaction, or no reaction. How I can decide? We can decide based on the given elements. This is a metal. Okay, so the metal will fight with another element from the same category, and so it will fight with another metal. Either the aluminium will win or it will not. How I can know? Look at the reactivity series here. Where is aluminium? It's here. And where is the lead? I'll use another color. And the lead is here. How I can know if it will win or not? Aluminium comes first, or so it's more active than lead. So aluminium is more active than lead, so it will win. It will take the place of lead. Becomes Al and O3. As you know, the charge of aluminium was positive 3, so 3 here. And the charge of NO3 is 1, no need to write the 1. Okay, and plus lead. Don't forget to balance always how we can balance 1 aluminium, 1 aluminium, 3 NO3, 2. So we have to multiply by 3 this side and multiply by 2. So we did a change here. This is a revision for balancing. So you have to change this side and don't forget to balance. Okay. So 2Al plus 3 lead nitrate gives 2 aluminium nitrate plus 3 molecules of lead, as it mentioned here, okay? This is what did I talk about, sodium plus water, okay? Gives sodium hydroxide plus hydrogen, and iron, which is from group 2, reacts with water, gives Fe3O4. And why did we do this chemical equation or chemical formula? Because it's FeO reacts again with water, producing Fe3O2 O4. Done. Now the reaction, now we talked about reaction with water. Let us talk about reaction with acids. When a metal reacts with acids, it replaces the hydrogen. Shian, what do you mean by this? When a metal, when a metal reacts with acids replacing hydrogen, for example, sodium from series number 2 can react with hydrochloric acid. As we said, an element plus a compound, so it's single displacement reaction. We will deal with these acids. The first one is positive and the second one is negative, okay? And the metal, always positive ion. So sodium, try to replace the hydrogen. Always sodium, magnesium, calcium, group 1, group 2 elements can replace the hydrogen. So the new product is hydrogen alone. When it's alone, so you have to write 2 with it, okay? At room temperature, it's in gas state, plus Na Na bonds with Cl. Na is positive 1, so 1. Cl is negative 1, so it's 1. Okay, so NaCl dissolving in water. Don't forget to balance the equation, multiply by 2, multiply by 2. So when a metal reacts with acid, an element with a compound, so a single displacement reaction, always group 1, group 2 elements can replace hydrogen from the acid, producing hydrogen gas and a salt. Okay. Another example is the reaction between magnesium and hydrochloric acid. Magnesium, as you know, it's in from group 2, so the charge is positive 2. So it's MgCl2 and producing hydrogen gas as H2 gas. Displacement of halogens, I'll return back to the reactivity series to show you sequence or the activity of metals. As you know, fluorine has the highest electronegativity values, which is equal to 4. When I'm saying electronegativity values, yani ability to gain electrons. So that when the ability of gaining electrons increases, so the reactivity also increases. Okay, fluorine more active than chlorine, than bromine and iodine. Okay, so if there is a chemical reaction between halogen, yeah, and a compound contains also halogen. For example, here Cl2 plus potassium bromide. I'll write the equation to explain it. Cl2 plus KBr gas dissolving in water. We said the sequence as per the periodic table: F2, Cl2, Br2, I2. Okay, fluorine is more active than chlorine, fluorine more active than bromine, so Cl more active than Br. I didn't say that Cl more active than K. We said before you have to compare between two elements from the same family, from the same category, that are similar to each other. This is a non-metal. So you have to compare it with another non-metal, not with a metal, okay? Non-metal. As per the reactivity series, Cl comes before Br. So chlorine more active than bromine. So it will take the place, chlorine will take the place of bromine, and bromine stay alone as Br2. Why did I write 2? Because it's diatomic element again, plus K plus KCl, okay? And we have to balance, multiplying by 2 this side, multiplying by 2 this side, okay? Here is the chemical equation for the reaction between chlorine and potassium bromide. Another example, Cl2 plus Kf. Cl2 plus potassium fluoride. In this case, there is no reaction. Why there is no reaction? Because as per the reactivity series, chlorine comes after the fluorine. So chlorine is less active than the fluorine. If you look again to the reactivity series, okay, chlorine less active than fluorine. So there is no reaction in this example, okay? More examples, F2 plus NaCl. I know that fluorine has the highest electronegativity, so it's the highest reactive element that has the highest reactivity. Fluorine can replace the chlorine, forming a new compound, sodium fluoride and chlorine gas. Bromine liquid, less active than chlorine, so it cannot replace the chlorine, so there is no reaction. In double displacement reaction similar to single displacement reaction, but single displacement reactions, it's a reaction between element and compound. In double displacement reaction, it's a reaction between two compounds. One of them or both of them are dissolving in water. So let us read the definition and the notes about double displacement reactions. And double displacement reaction, the ions of two compounds exchange places in an aqueous solution. When I'm saying aqueous solution, means dissolving in water to form two new compounds. One of the compounds formed is usually a precipitate. You learned the meaning of a precipitate before, which means solid. Insoluble gas that bubbles out of the solution or molecular compound, usually water. We will talk about when water is formed in a neutralization reaction. The other compound is often soluble and remains dissolved in water. Now, solubility is not our lesson, it's not our topic. Solubility, inshallah, you will study solubility on other grades. Double displacement reaction, as I said, a reaction between two compounds, forming new two different compounds. As you know, if the compound is ionic compound, always the first element that comes first, positive, and the second is negative, positive, negative. So what will happen? The positive from the first compound bonds with the negative from the second compound, and the positive from the second compound bonds with the negative from the first compound. So AY plus BX, I didn't write AY plus XB because always first you have to write the positive followed by negative, okay? For example, there is an example Ki plus or potassium iodide plus lead nitrate, both of them dissolving in water. As you know, K, what we will do, how we can solve this example, you have to write down the charge of each element. K is positive 1, iodine is negative 1. When they dissolve in water, they will form soluble ions. Lead has different oxidation numbers. I can know the charge or the oxidation number by looking at the subscript, second one. There is a method how to find the oxidation number that you will learn later. And the NO3, I know that the charge is negative 1. So potassium positive 1, iodine negative 1, okay, lead positive 2. So what will happen? The positive ion from the first compound bonds with the negative from the second compound and exchange the charge. So you will get KNO3 1:1 the ratio. And the positive from the second compound bonds with the negative from the first compound, lead iodide, okay? Lead to iodide. And you have to balance the chemical equation. One of the product is a solid or a precipitate. You can mention it like this by downward arrow also. Another form of double displacement reaction is the formation of gas. If iron 2 sulfide reacts with hydrochloric acid, as we said, the first one is positive, second negative, positive, and negative. The positive ion bonds with the negative ion, and the positive ion from the second compound bonds with the negative ion from the first compound, forming H2 as gas and Fe2Cl2 aqueous solution. This is gas, okay? And Don't forget to balance. Formation of water. This is that I will talk about how for before. Now I'll talk about formation of water. Formation of water in a double displacement reaction occurs when an acid reacts with a base. Acid plus base reducing salt plus water. All of us know what we mean by base, which is OH. And there's two types of acids, either binary acids or oxyacids. Binary acids start with hydrogen followed by halogen, or maybe sulfur also, like HF, HBr, HI, HCl. Oxyacids, hydrogen followed by a nonmetal, ends with oxygen. For example, H2CO3, H2SO4, H2SO3, HNO3. Okay, these are examples, some examples of oxyacids. When an acid reacts with a base, there is a metal, okay, metal hydroxide. The products are salt, we learned the meaning of salt before, and water. Let us take an example about, by the way, this reaction is called neutralization reaction. It's a reaction between acid and base producing salt and water. Here we have a binary acid, hydrochloric acid, dissolving in water, reacts with sodium hydroxide, it's a base. And here is an acid. As we said, hydrogen is +1, chloride -1, sodium +1, hydroxide -1. So what will happen? The hydrogen from the first compound bonds with the negative hydroxide from the second compound, forming water. So the water comes from the reaction between H plus and OH negative. Okay, and the remaining ions are sodium and chloride. Sodium ion and chloride ion, sodium ion and chloride ion forming NaCl dissolving in water. Okay. Last type of reactions is the combustion reaction. Combustion reaction in the presence of oxygen. In a combustion reaction, a substance combines with oxygen, releasing a large amount of energy in the form of light or heat. Example of combustion reaction is the producing of water by the reaction between hydrogen and oxygen, combustion reaction of a propene, or combustion reaction of organic compounds. When organic compound, take this as a rule. Organic compound, we learn what we mean by organic chemistry. Organic compound, it's a compound that contains carbon and hydrogen. Carbon and hydrogen. When an organic compound reacts with oxygen gas, O2 gas, the products are always the same. Water, carbon dioxide, plus energy or heat. Okay. Let us take an example for organic compound. Reaction of propane, C3H8 gas reacts with oxygen gas producing carbon dioxide gas plus water and heat. Okay. Another example, for example, I'll give you another example. Reaction of CH4 gas plus O2 gas producing always the same product, CO2 gas, water, H2O gas, and heat. You have to balance the chemical equation, multiply by 2 this side, 2 oxygen, and multiply by 2 this side. Okay? Always the same product. That's it for lesson 2, chapter 8, lesson 2, types of chemical reactions.